Okay. Okay. So last time we ran out of time before we finished the talk about handhelds, the history of handheld stuff. So this is kind of where we were. We used to have to put these enormous cards into our laptops in order to get Wi-Fi. Bluetooth is fairly new. Apparently there's a brand new configuration for Bluetooth that lets you do multiple devices, which they're starting to use for some game controllers and things, but that's pretty new. So the iPod was really a very revolutionary handheld invention that came out. It was, there were a whole bunch of media devices, of digital music players at the time, but obviously the iPod really took off in 2001. One of the key innovations was this dial. Did anybody have a dial iPod? You guys old enough to have been playing music at the time? The issue was that these devices held like 1,000 songs, and scrolling through 1,000 songs with an arrow key was obviously pretty tedious, and trying to do it by keyboard or something didn't make any sense for a portable device. And so if you ever tried one of these, it turns out that Apple had done an enormous amount of very careful user interface design to make sure that you could use this dial to go to the next song or to go to a song 500 songs away, right? And so if you study the design, it wasn't just the fact that there was this dial, but the fact that the software, the engineering, and the human factors behind the scenes made it so that you could really get to the song you wanted really easily, effectively, and quickly. And so it really was part of the whole interaction design. But it really also was part of the whole service design. So the iTunes Store actually came out before the iPod came out, and Apple was able to coordinate with a whole bunch of music vendors so that there really was a lot of music to choose from that was relatively inexpensive, and so people could get the songs they wanted onto their digital device really easily because you just plugged it in and it was there. The original devices actually had a physical hard disk in them, a little spinning hard disk. They were really cute if you ever opened one up to look at the hard disk inside. The same kind that are used in laptops, but much smaller. Nowadays, of course, you can just use flash memory, but at the time, flash memory didn't exist, and so you needed to use physical hard disks. It was very innovative. Of course, the iPhone came out quite a number of years later, 2007 already. Already it's 7 years old. It's a shame we didn't do this contiguously with the last lecture, but if you remember with the original Palm Pilot had come out with this full screen and a soft keyboard and the graffiti alphabet, and there were a bunch of other devices that had soft keyboards and full screen displays, and those had all kind of gone away from that. So the iPhone switched to using a BlackBerry kind of keyboard. The BlackBerry was all the rage in terms of how people wanted to do text entry, and thumb. Everybody was getting good with their thumbs on devices. And so the iPhone came out with no keyboard, right? Didn't have any buttons at all except for the one button in the center, the home button, and it was entirely a soft keyboard. It also switched from a stylus. There's no stylus with the iPhone. Every previous device that had a stylus. And it has, this very attractive design. So what are some other aspects of the iPhone design that were unique, that no one had seen before? You guys all have iPhones, so yeah? Right, so it was designed to be really simple. If you remember back to the discussion of the original Macintosh, when it came out in '84, and the Lisa in '83, it had one button mouse, right? And the goal was to make sure that everybody could figure out which button to push, right? A lot of the same philosophy went into the iPhone. Which button do you push if you're confused? Well, that's easy to figure out. There's only one button, right? And so if you push the one button, then it'll get you back somewhere that you can be comfortable with. What else? Yeah? High resolution display, yeah. Lots of other people had high resolution displays. So. Right. Right. So the original displays the original touch pads, the touch screens that all the previous devices have were called resistive technology, and that's why you could use a stylus. This is a totally different kind of technology for recognizing your fingers, which can accept 2 fingers, right? And so that allows the 2-finger zoom and rotating and all sorts of other gestures with multiple fingers. And it also, of course, means that you cannot use a stylus with this thing. If you have a really pointy thing and you try and tap on the screen, it doesn't even notice it. Anybody have a stylus for their iPad or their iPhone? Right, there are these really big, thick, ugly tips, right? Because it turns out a really pointy, no one's figured out a way to have a really pointy stylus for this kind of capacitive technology. But the advantage is that it lets you do these kinds of innovative interfaces that are multiple fingers. Somebody back here had another idea? Yeah? The accelerometer, right? So there are other kinds of sensors in the device, like the accelerometer, which originally was mainly used to tell if you were horizontal or vertical, and it oriented the content appropriately, which is, really useful. That has, it wasn't an invention of theirs. There had been previous devices that have done that, but you hadn't really seen that on any of the standard devices. Any other thoughts? Yeah?
I think they had an infrared sensor that detected when you were holding the phone close to your face. So it was able to detect.
Yeah, so one of the problems with a full screen display, which you don't really have with a RIM keyboard, is that when you hold it next to your face, you tend to push buttons by accident, right? That your cheek will push some of the buttons on the screen. And so one of the ways that they figured out to avoid that was that in the little slot up there that's the speaker, or sometimes next to it, is actually a little sensor. And if you hold your finger, you can tell it's checking to see if anything's really close to it. So when it detects that it's really close to something, it turns off the screen and turns off the sensor. It also saves battery life, but the primary goal was to make sure you're not pushing all sorts of buttons when it's against your cheek, because then you just do things you didn't intend to. And so you can actually play with that. If you just put your finger there while it's in phone mode, then it'll turn off. So that was an important thing they added. Yeah? Yeah, so if you wanted to, it turned out the first year it came out, it didn't have the toolkit. It came out in the second year. But if you're a Mac developer, then you'll find developing for the iPhone pretty familiar. It uses the same tools that you use for, for developing Mac software. The same editor, the toolkits are fairly similar, language is similar. That wasn't an innovation, because all of the Microsoft products had done the same thing. Palm Pilot had a totally separate environment, but all of the Microsoft, the CE, remember we talked about Microsoft CE, they had the same philosophy. If you used Visual Studio to develop for PC, then you'd be familiar with how to use Visual Studio to develop for your Windows CE phone or Windows CE device. So that was definitely a property of this, but it certainly wasn't an innovation that Apple provided. Any other thoughts? Yeah? The home button, what about it? The only global control. Okay. Yeah, the Windows devices had a menu button. A bunch of the other previous handheld devices had a variety of things that all of the applications were supposed to be able to manipulate or respond to. Okay, let's see what I had on my list. Pass, stylus, one button. Oh, okay. So interaction techniques. The scroll bounce we talked about before. If you scroll to the end of a list, like the end of your contacts, then it bounces. That was an innovation that they provided. The swipe to log in was something new that the iPhone provided. Can anybody think of any other interaction techniques? So we mentioned the zoom with 2 fingers. Are there any other interaction techniques on the iPhone?
I think there's a slight difference in like Boolean controls, like from just being a checkbox to actually being a switch.
Mm-hmm. So the slider that went back and forth, originally you actually had to slide across, but in some version of the operating system they made it so that you could just tap on it. You don't have to actually slide it anymore. Originally, for all of those choices, the little checkbox was a physical, modeled the physical slider, and you had to slide across. So yeah, that's something people hadn't previously done. Any other thoughts? Yeah. So if you try and set a date on an iPhone, it pretends that all the dates are on a roller, and if you flick it, it rolls, and so you can get to dates that are far away fairly quickly by flicking quickly. So it works in the same way as contacts and other things. But it's on an infinite roller because it'll wrap around. Right? So it's like it's on a big wheel. Yeah.
Voice interaction.
So the current models have Siri and voice interaction. The simpler version they had before that, where you could say some simple commands, all the previous phones had that as well. So there really wasn't anything very novel. Dial home, all of the devices, all the phone devices tried to have some way of doing it. The interesting thing about Siri is that it's being done offline, that Siri is actually in the cloud. It is not on your phone. The simpler kinds of recognition are on the phone itself. But what Siri, and also Google Now does it the same way, is that it takes your voice, processes it a little bit, sends it off to the cloud, lets the cloud do the recognition, and then sends it back to the phone what it's supposed to do. And one more thing. This area down here? Yeah. So, that lets you have the same icons always available without having them as hard buttons like they were on the Palm Pilot. Okay. So Android was announced the same year as the iPhone, but it didn't actually come out till a year later. Google's giving it free to the phone manufacturers. The actual operating system is open source. It's based on, it's actually Linux behind the scenes, and Java. So mostly as a programmer, you deal with Java stuff. It turns out that if you're doing a user interface for Android, you have an awful lot of targets. There, according to one source I looked at, over 700,000 different types of devices that run Android right now, in terms of all the different phone models, all the different tablets, all sorts of things. And across all those devices, as you can imagine, there are hundreds of different screen sizes. Virtually any size you can imagine, somebody's built an Android device for it. This is a fun chart. I'm sure you've seen versions of this. This is Nokia, this blue line. They used to be a real dominant player with their Symbian operating system, and not so much anymore. Purple is iPhone, which has stayed surprisingly stable, right? So, it's never really been a dominant, the dominant model in terms of market share, but it has obviously been the dominant model in terms of design. So they're, kind of hovering around 15-20% for quite a while, even though you would think that, everybody has one. That's actually not true. The other important one, of course, is, Android, which is just going up exponentially, and RIM, which is red, BlackBerry, became a very important business device for quite a while. And then eventually, Apple and Android got to be supported by the business backends. The people in the high-level executives in these businesses decided they really were tired of carrying around their BlackBerry and their iPhone, and so they finally got their businesses to accept BlackBerry and Android and iPhones, and so nobody wanted to carry their RIM devices anymore, and the designs have been pretty unpleasant. So they're really having trouble. And Windows Mobile has never made any impact at all. So it's been kind of also ran forever, and the new version doesn't seem to be making any difference. And it's not so obvious to me why that is. Because the new design, anybody have a Windows phone? Nope. One person. Okay. I think that, what do you think of the design?
I actually really like it.
Yeah, I think the design is pretty cool. The squares and what do they call them? Active tiles or something. And it's pretty much the same capabilities as all the others. There are not nearly as many apps for it, but somehow it doesn't seem to be catching on. And then we get to tablets. If you remember from last time, there were all these people trying to make tablets. It was a really big thing for a while in the 80s with the Pen Point and all those GridPad, all those tablets. Then Microsoft tried to have a big push with tablet PCs, which never took off. But the iPad obviously has totally changed the world in terms of, how many people have tablets or what people want to use tablets for. It's a very different model of what people would use this for compared to a tablet PC. So the iPad, when it came out, is a big phone, right? So it looked like all the phone mechanisms. It worked like the phone. It didn't try at all to be anything like a Macintosh or a PC. And mainly people used it as a media machine, as a way to read books, as a way to watch movies, to play games. Kind of the initial set of uses pretty much involved all of these kinds of media, consuming media, and not too much about authoring, right? So tablet PC was about handwriting recognition. It was about, using conventional PC applications. None of that was really available for the iPad. Any other thoughts on why the iPad was so successful when the tablet PC and all the predecessors were so unsuccessful? Yeah.
Didn't it have the advantage of being able to kind of pull from the existing iPhone application pool?
Right. So that was a great thing that the hundreds of thousands of applications that had already been built for the iPhone could be run immediately, and you'd just get them bigger. Eventually, it was fairly easy for application developers to figure out ways of making use of all the extra space, but if they didn't, you still could use them. So photos might have been an app. It'd be interesting to see what the kind of main uses when it came out is. Another one is that the technology had finally caught up. You could use this for a day or two on the battery charge. It wasn't like the original pads that died after a few hours. 3 hours of use was silly. The weight is way down now because the technology finally got advanced enough that the batteries would last all day without being enormous. Yeah.
Just the physical design was really sexy. It was like, the previous tablets that we saw some in class were really bulky, and this was something very streamlined. And I think that it was one of those things, like a jewel that people just wanted to touch it and have it.
So there's, the emotional component, the whole experience, and certainly Apple is an expert at making devices that are attractive. And there's all sorts of interesting aspects of the physical design if you look at it. The back is curved a little bit, so it looks thinner than it actually is, even the original models. Obviously, the Air is incredibly thin, but even the original models had a lot of curves to make them feel less boxy and more attractive. So here's a quick question for all you designers. On the iPhone, the screen pretty much goes edge to edge, right? Here, there's a rim all the way around. Why doesn't the screen go to the edge? Yeah?
And you can't do it. I think it's way too big, so you need
Right. Is that what you were going to say? So there's no way to hold this thing without having your fingers on the front. And so a bunch of people said, oh, it should have had a bigger screen. But then there would be no way to hold it without your screen with your thumb on the screen. And it's still the case for some applications that I'm always screwing it up because my finger moves slightly off the black part onto the screen part, and then it starts thinking I'm holding it in two different places, and that changes the way that you interact with it. So that part of the design, obviously, they were paying attention to. Okay. So as I mentioned last time, I tried to make a timeline. I was looking for timeline software. I figured there'd be a lot, but there wasn't. I could only find a couple. And this is one that would let me upload a spreadsheet of numbers. But for some bizarre reason, it just left out a bunch of the things I added to it. So I'm not so excited. But anyway, if anybody knows of a good timeline software, it'd be good to enter all this stuff in it so you can kind of see how they go with each other. There's a whole bunch of other portable devices that I didn't cover in this quick overview. Did anybody ever have a personal organizer? So they used to make these devices before PDAs that were just organizers. So you put all your addresses and phone numbers in. It was kind of like a big calculator, and you type them in. The problem was typically they would lose everything if the battery died, so they were really stupid. I thought that was kind of dumb. Do you have one?
Yeah, I had one. I had multiple, like the gassy one.
Mm-hmm.
And yeah, I also had like one for dictation.
A dictionary? Yeah. So, and they had little keyboards, and you can enter all this sorts of stuff, but they tended not to work very well with PCs and things. Didn't really cover book readers, so there's been a long history of people trying to make electronic books. It didn't become really feasible until the e-book technology, the kind of screens, e-ink, I think it's called, that it was actually invented by the MIT Media Lab. And what they are teeny little balls that are black on one side and white on the other side. And it actually, using electronic mechanism, electrostatic mechanism, rotates them one way or the other. And that's why they don't take any power, and that they can be seen in overhead light. There's actually not a light in them. It's actually either black or white physically. So that the original Kindles used that technology along with some other devices like the Sony book reader. They can be really light because they use a much smaller battery. Most of the weight in these things is the glass and the battery and the steel to make sure you don't break the glass. So the first Kindles use plastic screens. They can use a really small battery because they don't need much weight, much power, and that made them much more practical. And there's a bunch of specialized devices. So I showed you the big Palm Pilot with the laser scanner in it, but there are many, many devices made for medical systems, made for warehouses, and all sorts of other vertical markets that we didn't cover. But if anybody has any knowledge of any of these or has one that they used to use or something, it'd be fun to see them. Okay. Any other thoughts or comments on kind of the big history of handheld devices? We're obviously going to cover the interaction techniques in detail later. Like today we're going to talk about desktops. Next, in a couple weeks, we're going to talk about menus. So we'll get to some of the particular features of the devices later. Yeah. So there's been this tension throughout the desktop and throughout the computer era, and this originally for desktops, but also for portable devices, of how much computation, how much storage do you want on the device itself, and how much are you okay with it being in the cloud, is that we call it now. Originally it was called client-server architecture, which is pretty much the same thing. So they had devices in the 80s that were these enormous monitors where the computation was all on the server or on the cloud. And nobody really wanted those. It was called the Blit terminal. There was a bunch of attempts to do that where you really didn't have any local storage. And with the web, people tried that again. And so there's kind of always been these attempts to get people not to store things locally, to store them on the servers, and then the advantage is you can switch machines really easily. You don't have to worry about backups. The disadvantage, of course, is sometimes you can't use your device at all, like when there's no network around. You can't really own stuff because somebody else is keeping it for you. There's always the risk that stuff will disappear, and so there's a variety of disadvantages to that. So there have been a bunch of these kind of devices at every level. There were desktop machines, laptops, and handhelds, and maybe when people get comfortable leaving everything in the cloud, that they'll be more successful. But for the time being, I think people still want stuff locally so they can feel more ownership. Anything else? Okay. So today's topic is desktop metaphors, and there was some required reading, so we have a little quiz. This one's the answer sheet, so you don't get that one. So everybody put their stuff away. Hopefully this will only take like 5 minutes. And tiled. So did they have menus of window manager commands available? How many people think overlapping windows had those? Yes, they did. How about tiled? Yep, so that was both. Users can grow individual windows. Overlapping? Yep. Tiled? No, you couldn't grow individual windows in a tiled system. You could only move the bar back and forth or up and down, so that you always were changing the size of at least two, if not the whole column of windows at the same time. Windows can be shrunk to icons, overlapping, tiled. Yeah, so there were systems where both of those were possible, where you could click on a window and make it shrink down to an icon and disappear. Operations are generally performed with a light pen and a panel of levers. Hopefully nobody checked that. That was left over from Sketchpad back in the 50s. So that was neither. When new windows are created, the system decides where they go. Did anybody see that in overlapping systems? No, the systems of the time. Huh? Not sometimes. Sometimes you had to actually drag them out. It certainly was the main thing for tiled windows. Operations are generally performed with the mouse, both of them. That was just silly. The background behind the windows in the early systems was colored blue for covered windows, tiled. All of the early systems were black and white, so there was no color at all. So this was neither. An important design decision was whether the windows that are not on top can accept keyboard inputs. Overlapping, that was one of the things that was really emphasized in the video. For tiled windows, there's no such thing as being on top, so that's not relevant. Windows have title lines. That was for both. And there can only be one listener window. Overlapping, tiled. The listener window concept is what goes with the keyboard. There's always only one keyboard, so that's certainly for both. Okay, systems discussed in terms of icons. Icons represent files present in the system. Who thinks that was true? So that was like the Macintosh, right? Every file was an icon. They represent different users of the system. None of the systems we looked at did that. Eventually, of course, you could get, icons for different users, but that wasn't something we saw in the ones we looked at. To represent actions that can be applied to the entities. How many people saw that? Yeah, so that was, even on the original Star, you could print things by dragging it to, of course, everything has trash cans that you can delete by dragging things to it. Icons that represent windows that are currently visible on the screen. Which system had that? Anybody? The Sapphire system had icons at the same time for both things that were there and not there. How about when icons for windows that are not visible? That was most everything else, where you could just shrink a window down to an icon so that you only saw the icon. And to show progress and status of processes, we can do that in the Sapphire system, and a few other systems showed, whether it was operating or not. Yes? Whether it was printing. Right. So would show whether there's new mail by changing the mail icon. Okay. So hopefully everybody got all those right. It's pretty clear from the videos how these all worked and how they should be provided. Okay, the homework, as I sent in an email to everybody, we decided it'd be easier to grade if you turn in paper, so please print them up. If there's some problem with color or there's some other problem, just let us know. If you're out of town and want to turn it in on time but can't actually physically do it, then you can use Blackboard if you need to, but we'd prefer to have a paper, and we're going to ask you to turn it in before lecture, so hopefully everybody will come on time and turn theirs in before the guest lectures. Any issues? Jeff is going to have an office hours right after class, so if you have questions about homework 1, then that would be a great time to ask about it. Or, if you're doing it over the weekend or at the last minute, we'll respond as soon as we can, but not necessarily immediately. We just put up homework 2, so if you're feeling adventuresome, you could look at that and see if there are any problems with it. Instead of doing a user test like this one, we're asking you to just do a broad survey of different kinds of menus and compare and contrast them and look at different features. And then in terms of the schedule, let's go to, looking at the schedule here, so we have the new homework here, if you want. And in terms of the schedule, we have the guest lectures next Monday and Wednesday, and then I'll have a lecture on menus the following week on Monday, and then the homework's due the week after that on Monday, here on the 17th. Okay. Any logistics issues? Okay. So we're going to talk about a brief history of window managers, desktops, icons, that kind of thing. The first systems in this kind of general category separated a fairly standard screen into horizontal strips, or panes, as we probably now call them, although that wasn't the original name. Bravo Editor, as we mentioned a couple lectures ago, had that ability where you could see multiple views of the same document or 2 documents at once. People realized pretty early that it was going to be really useful to compare different documents, to be able to see 2 things at a time, and so that was the easiest way to do it. It didn't really require anything special in terms of implementation in order to make that work. And this dates back to the 70s. We have the Bravo editor from 74, Emacs as early as 76, and there probably were lots of other systems that did this in the CAD/CAM area and some of the early systems, and I don't know of any others, but I'm sure there were lots. As we mentioned a couple lectures ago, Alan Kay is credited with inventing the idea of covered windows, of having windows like we are familiar with them now, and that was in his PhD thesis at Stanford way back in '69. He couldn't actually implement it at the time, so he implemented it when he got to Xerox as part of the Smalltalk environment. And as we discussed before, the Smalltalk took over the whole screen and was everything that, the programming environment, the interactions, everything was Smalltalk. And I used this in 76 or so. Eventually, it was released to the world in 78 or something, but it dates back to 74. There were actually versions of Smalltalk before that, but they didn't have the windowing system that we're all familiar with. There's a little story about the covered window model that it turns out in Smalltalk, the windows did not update when they were covered. So if something tried to draw to this window, it would pop itself to the front and then draw. Right? And you can imagine that it's easier to implement a graphics operation if you can just clip it to a rectangle, clip it to the window, rather than having to figure out, which parts of it you can actually draw. So if you're trying to, write some code that would draw a circle, and you have to clip it, to the particular parts of the window that are visible, that's actually fairly tricky math, tricky graphics operations to support, especially way back in this time period where memory was very expensive and you couldn't really afford to draw an extra copy and then print it to the screen. The video talks a lot about focus window, the listener window, and again, since you could only draw to windows that are on top, then certainly the focus window would always be on top, the window that the keyboard is connected to. In the video, it showed that I think it's the right mouse button or some mouse button that you click anywhere, and that would pop up a list of menu commands, including things like bring to top, send to bottom, make full screen. They had two different ways of changing the size. One where you pick a corner and change the size, and one where you just draw a new box, move and close, etc. So fairly, you would be familiar with this window system if you saw it. A lot of the things are the way we'd expect, possibly with the exception of some of these commands. So as soon as the Smalltalk environment came out with this windowing system, everybody else at Xerox wanted their own windowing system too. And so all the other environments so Xerox was a big place, Xerox PARC. There was like maybe 300 researchers, so it's really quite a large lab. There were 2 computer science groups, plus a whole bunch of hardware groups that I didn't know anything about. There was a chemicals group. So Xerox PARC we've all heard of in terms of user interfaces, but they actually did a lot of important research in networking and printing and lots of other aspects that Xerox might have been interested in. So the Smalltalk group was just a small group of maybe 10 people, and everybody else, was highly influenced by what they were doing, and so they were also interested in having their own window managers. So there was a variety of programming environments for the programmers to use, including the people who were building the star. So we talked about the star before, which came out in '82, and it took many years of programming to develop it. So they wanted a nice programming environment like the Smalltalk one. So they built one called Tahoe, which eventually was called XDE, which you saw in the video, that also had a, Sigh. Well, as soon as it finishes, then it has to cool down, then it'll come on again. But you've seen all this on the video anyway, so you don't need to see the pictures. So the XDE, the Tahoe environment, had some pretty bizarre interaction techniques, it turns out, if you paid attention to the video. One of the things that they didn't specifically mention was it was designed for a 2-button mouse, but they had all these 3-button interaction techniques so that they made you chord the 2 buttons to represent the middle button. So it mentions, you push down one button and then you move and then you click the other button at the same time. So it was kind of bizarre interaction techniques. Interlisp D was the Lisp environment that another group of researchers there was using, which also had a window manager. They also had this thing where the windows would pop to the front when they wanted to output, because nobody had really worked out how to output to covered windows yet. So the Interlisp D environment was a few years later and also had the idea of icons because that had been introduced from the star. You notice the Smalltalk environment didn't have any icons. That had come out before the star had introduced those. Okay, now it'll warm up and come back on. So the next system, which hopefully will come up before I finish talking about it, it actually wasn't in the video, but probably should have been, was a system from the MIT Media Lab, which at the time was called the Architecture Machine Group. How many people have heard of the MIT Media Lab? Some people haven't. So it's an important research group at MIT. It's not in the computer science department, and there's been a bit of rivalry between the two departments for 30 years. It's actually from the architecture group, which is not surprisingly why it's called the Architecture Machine Group. And it was founded by this guy, Nicholas Negroponte, who was an architecture professor. And he had this little group that was designed to study media. And they did all sorts of really important innovations at the time. So this picture is from 1978. So that's a really old system. There are these two enormous monitors over here. They're both touch screens, so you can touch them. And in front of him is a giant projected screen. So that it wasn't a touch screen, it was a projector, kind of like this one, except it was back projected. They had built this whole room that with a lot of very special and expensive hardware. And so you could touch on these devices to tell it which part you wanted to see. And this spatial data management system was a very important, influential system in the concept of having basically an infinite space, a really giant space, and you just put stuff all around on there. So it was not like having a hierarchical file system or any of the other kinds of systems that we're familiar with. The idea was instead of having a regular database or a query or a file system, you just put everything on this infinite sheet and you'd scroll around till you found stuff, which is a pretty clever idea for tens of things. Obviously, it breaks down if you have hundreds or thousands of things. It was one of the first systems to have things like calculators and other, graphical presentations of conventional desktop kinds of things on the screen. So it was also one of the first systems to have things like movies and maps represented on the screen. As you can imagine, it was pretty early for doing lots of that kind of thing. And this idea of having kind of this infinite sheet that you use to move around on was picked up in the 90s with a couple of important systems, PAD and PAD++, that also have studied this issue of how to have kind of this infinite sheet and let you scroll in and zoom in order to get to the data you wanted. Sometimes they're called multi-scale architectures. So pretty influential in terms of how to lay things out and support zooming in things. Oh, and the semantic zooming idea is, again, still from the original 78, although they didn't call it that. The idea is that if you're at this level of detail, then you just kind of want an iconic representation of the things that you're looking at. But as you zoom into them, then you want a more detailed view. So it's not like a physical zoom that when you zoomed out, everything would just be blurry. But instead, you can replace the representation with a different representation that makes more sense for the level of zoom that you're at, right? So that if this was, a map of the United States, or this was a calculator, then you might just have some representation that showed you what it was at this level of resolution, and when you zoomed in, then you would get to see the details because it would just replace the picture. So Google Maps does this now, right? You don't see the building outlines very little. When you zoom out, instead you see, the roads. And if you zoom out far enough, it gets rid of the roads and shows you the mountains or whatever. So this idea of having different representations at different levels of zoom dates way back to 78. Another important system that wasn't in the video is Pygmalion. So David Canfield Smith, who's going to talk to us on Monday, named the idea of icons, and in the chapter that he wants you to read that I put on the website as a link, it has this little discussion about how he came up with the name, and it was basically representing the Russian Orthodox religion uses icons, religious icons, to represent not just the thing that it's representing, but also a lot of other things as well. And so it's a pretty interesting origin of the name. He called these icons. And it's basically doesn't really have anything to do with the desktop. This was a way of trying to help people program. That was his concept, programming by example. It's also interesting as the first system that had that was implemented in Smalltalk. He also was one of the first systems that allowed you to drag and drop icons, and when you drag them on something, it would do something appropriate. So a lot of the interactions that we have come to expect were actually first shown in this system from '77. So David went on to be one of the designers, one of the chief designers of the Xerox Star. And so obviously he brought the icon idea over here, and you could drag things into folders and into the printers in order to get things to happen. Another interesting thing about the Star is that unlike Smalltalk, it was a tiled window manager. It's kind of surprising. Eventually they realized that wasn't going to fly, and they switched to a system they called Viewpoint, which was the same system except it now supported overlapping windows. But the Star had gotten a bad reputation, so they changed the name. Icons represented all the data as well as the operations, and there's this really interesting interaction that you're supposed to read up for next time, looking at the video to show how they use special keyboard keys in order to do all the interactions. So I'm not going to talk about that very much today because it's what you're supposed to read about for Monday. The Cedar system was another important system from Xerox, and it was very influential because of this tiled design. So, and it also had icons. And the thing that they discovered was that, so the original idea was that graphics was expensive, and if you wanted to support drawing circles and drawing fonts and stuff like that, it's fairly tricky to figure out how to draw to windows when they're covered. But they wanted to have the ability to support multiple processes, to support things that output while they're covered. And so in order to do that, they decided, well, let's just make it so nothing's covered. And clipping to a box is really easy, but clipping to the arbitrary covering is pretty expensive and tricky. So they decided, let's make the graphics a lot simpler. We'll just have rectangles, and then we'll help people by putting the windows around automatically. So in Cedar, the new windows always popped up to the bottom of a column, and you could move things around. And if you change the size of something, it would try to figure out how to allocate space appropriately. And Cedar didn't have anything particular intelligent about how the sizes were allocated, but the Andrew system, which used a similar design and came from here, tried to be really smart about how much to grow windows and how much space each window should take, and if you created a window, how much to shrink everything else. So there was a big debate kind of going on at this time in the early 80s about this distinction, this battle between tiled windows and covered windows, and which one was better. And I think I assigned a paper where somebody tried to do a human factors experiment based on this, but of course there are so many confounds, it's kind of a dopey experiment. We probably wouldn't get this kind of paper accepted into Chi anymore because it's really didn't control for enough of the variables. But it did show kind of the obvious thing that in a tiled window manager, people don't spend so much time fiddling around with the windows, but instead they get annoyed that they can't quite get the layout the way they want. Whereas in a covered window manager, people can get the windows exactly like they want, but that takes more time because they have to do it by hand. The Andrew system was developed here in the Information Technology Center, which is now where Sires Hall is, behind Warner Hall, a little black building. At the time, it was just called the ITC building, and the whole building was built with funds from IBM, and they filled it up with a bunch of top-notch researchers, all paid by IBM. Jim Morris, anybody know who that is? He's the current, I guess he's teaching some classes. He used to be the dean of the School of Computer Science, the department head of the computer science. He was head of the HCI Institute for a little while. He was actually hired away from Xerox PARC to head the Information Technology Center in 82 to 87. And the ITC actually had 3 really important contributions. The first was the file system. We still kind of use it here, Andrew file system. And they tried to commercialize it, but not very successfully. Another important contribution that we're not going to talk about at all is a component model for operating systems. And that has had enormous influence. The OLE model and currently the plug-in model that's used by most current like IDEs and things like that is all based on this component model that they invented with the Andrew system. But the key user interface contribution was this tiled window manager with its kind of weird set of menus, and we'll talk about the menus last time. The system did not have regular icons, but instead you could shrink things down to just their titles. So the titles would shrink in place, and so they would keep their same order in the columns. And they had a lot of fairly elaborate interactions that they developed to make this all work. So there's an interesting story, let's see, I guess I'll tell it now, about the Andrew system. How many people have heard of X Window Manager? So at the time, remember we were talking about workstations. So there was the Apple II, and the Xerox Star was this big honking machine, remember? And there was a whole bunch of companies like Three Rivers and Sun and Apollo making these expensive $30,000 machines. And each one had its own operating system. They were all different, and so people were spending a lot of time trying to make their applications run on these architectures. So if I wanted my application to run on Andrew, I'd have to write it using the Andrew toolkit. And this was running Unix. And then I'd want it to run on a Sun system, and it had Unix as well, but it had a totally different window manager. And then I'd want it to run on the Apollo, which was also Unix, but it had a totally different window manager. So people were getting annoyed that they had to keep writing their software over and over again to work on all these different platforms. And so there was this desire to pick one platform and have it all work together. But the companies really couldn't agree on which one it was going to be because everybody wanted it to be their own. And so the companies gave a bunch of money to MIT to form a consortium of companies to try and develop a common platform for everybody. And they called that, the consortium came to CMU and asked the ITC if they could use their window manager, which was called W. And IBM said, oh, no, we're not going to give that away for free. We just spent millions of dollars having this whole group of people build this. We're going to try and make money off of it. You can't have it. And so the MIT people said, oh, well, I guess we'll have to build our own. This one's called W. Obviously, ours will be called X, because that's the next letter. So that's where the X Windows system came from. It's because IBM said that they couldn't have this W system, so they made their own X system. And that was the origin of the X Window Manager. Now, on the videotape, you saw like the Motif Window Manager and some of the ones that are built on top of X. But the X Window system itself is just kind of this global system that was a consortium of people trying to work out a consistent API. So then the Lisa and Macintosh came along. This, again, was kind of after, all of these other people were working. And we're going to focus a lot on this in Larry Tesler's talk next Wednesday, so I'm not going to go over it in too much detail. The key contributions, of course, are to popularize the desktop metaphor, make sure everybody in the world had heard of all of these interaction techniques, made everything much easier to use. It was a covered window system, and the funny story about that is that Bill Atkinson, the chief implementer of the graphic system here, when he saw, so Bill and Steve Jobs and a few other people got to go to Xerox PARC and see all their stuff. Did we talk about that in a previous lecture? So he thought he had seen Windows update while they were behind other Windows, although nobody had figured out how to implement that at Xerox. So he thought he'd seen it, so he made it work, writing it all in assembly language for this 68,000 processor at the time. And so even in the original Macintosh, the windows that were behind could update. So if you had a clock and you had it covered, it could still tick, for example. And the low-level graphics package, which was called QuickDraw, which was all implemented in assembly language, had circles. So Steve Jobs insisted that we have rounded rectangles and shadows and different shapes and clipping regions that were not rectangular. And so all of this is built into the QuickDraw graphics model behind the scenes, nice fonts. And so that made it easy for the user interface to use all these features and look a lot nicer. And these little black dots here, you know, look a little weird in this screenshot, but when you had them on the screen, it fit in with the black, you know, part of the monitor where you couldn't see things, so it looked like the monitor was actually curved, even though it was square, things like that. So the windows that were behind could update, but only one window could be interacted with at a time, and that was the focus window was always on top. And you could only grow windows from this one corner, and you could only close windows from here, and you drag them around by clicking on the title. So, you know, modern Macintoshes have lots more controls than that, and the other ones were on the menus. There was the trash can icon that would do things, but unlike the star that had a whole bunch of other things that you could do, like printing and filing and so forth. Well, you could always do filing by putting things into folders, but for printing and everything else, you had to go to the menus. So they didn't really take this model of operations as icons very far in the Macintosh. In some of the later lectures, we'll talk about the animations that they added so that things were clear, but when you iconified something down to an icon, or when you use the menus, there'd be these little animations so you could tell what was happening. Yeah?
Do you know how much the original Macintosh cost?
Oh, I saw that somewhere.
If you don't know it.
It was like $2,500, or maybe that was the Lisa. The Lisa was pretty expensive, and the Macintosh was like half that, you know. But it still was, I think the Lisa was $2,500 and the Mac was $1,200 or something. It was still pretty expensive. But it's easy to find. It was definitely something I read recently. And the Lisa had a screen that was twice as big. So that's one of the reasons that this was at such a tiny screen. It didn't have a hard disk. There was an awful lot of compromises to make it. Maybe it was, he was trying to go for $1,000. It was something like that. This is the window manager that I made, Sapphire. It's actually my first silly acronym. Screen allocation package providing helpful icons in rectangular environments. And here was my Sapphire icon. At the time, nobody had this idea that you should hire graphic designers to do your design for you, so I did these myself. And you can tell, because I'm really not a graphic designer. But the idea was that there would be all these icons to show you what was going to happen or what things were doing. And it was somewhat of a modal system. So what would happen is when you click down, you would get the icon. And if you liked what it was going to do, then you released, and that would do it. If you didn't like it, you'd move away, and it would give you the abort icon, and then it wouldn't happen. And so the idea was that you'd get a lot of feedback on the way to doing stuff, and you could tell what you were going to do before you did it. Another thing that was an innovation is that I allowed full input and output to covered windows, so which window was covered which window was on top was completely orthogonal to which window you were typing to, and which window was outputting. And also the idea that the icons had all these progress indicators that would tell you how the thing was doing and what was going on, and that was not really reproduced until a recent version of Windows, I'm not sure which one, maybe 2000, where they started putting progress bars in the taskbar. So it was a pretty inventive system, I think. Got a couple papers out of it, but unfortunately the company went bankrupt, and nobody's really seen this for real. So Microsoft Windows version 1 was released in 85, and remember the Macintosh was 84. Lisa was 83, Star was 82, so these ideas were out there, and the original version of Windows had a tiled window manager, and the story I heard was that Microsoft hired away one of the chief designers of the Cedar window manager, who had done this sophisticated tiled system, and so he brought his code or design sense over and re-implemented a tiled window manager for Windows. That was not very popular, and so they quickly went to a covered overlapping Windows system for the next release, which took them 2 years. And nowadays, the Windows system has gotten a lot more sophisticated and with more and more different features. The original version had this ability to do any operation from the keyboard, and that has been retained. I also had that in Sapphire as well, where you could do any of the operations from the keyboard. And in Microsoft Windows, that was considered important. And so you can type the Alt key, and that would get you in a special mode where you could move and select menu items from the keyboard, from the arrow keys, and then you could grow and move windows from the arrow keys as well. 3.1 was generally considered the first one that was usable and successful, and that's when people started writing lots of code for Windows, and the rest of the different alternatives kind of went away. So it took quite a number of years. A system that I should have had in the video but didn't was called Rooms, and this was another Xerox PARC invention. The idea of Rooms is to collect together a bunch of windows that are useful for one particular purpose into what they call the room, and to let you switch rooms when you're switching context. So the idea was that sometimes you're reading email, sometimes you're programming, sometimes you're drawing pictures, and it would be nice to collect together all the windows that are useful for doing that task in one screen, and then when you switch tasks, you could get the windows that are useful for your other task and not having to keep moving windows around. And so the idea was that you'd have a room for programming and a room for doing mail, and you could just click on that room and then do that particular task with all the windows that you needed. The room system from 86 called it a suite of virtual workspaces, and they had these doors that would let you go from one room to another, or there was another view where you could zoom out and see all the rooms and click on it. So I guess it's the Macintosh has this kind of a built-in, and there are lots of X window systems and Windows that have this concept of having different organizations. The Macintosh one doesn't let you have the same window on multiple screens, though, right? Is that right? Or can you? Anybody know? Okay. So you can have one thing on every screen, or on one individual screen, but you can't have it on exactly two? Yeah. Okay. Okay. So this one is a little more flexible, that you could have an arbitrary set of windows, including the same application. I think it was the same. I think it would, if you had like the mail program, it would always be in the same state, independent of which room you were in, but you could have the mail program on two rooms and not on the third room or something like that. But anyway, this was kind of the origin of this idea of having these virtual workspaces. So this is just kind of a couple of last slides about newer features. Obviously, the videotape stopped at 1990 when I made it. So the question is, what's new since 1990 in the area of desktops and windowing systems? So one is the dock or the taskbar, which came out around 95. The dock, I think, was 99. That was the best date I could find looking around. I'm sure many of you guys remember, but it would be interesting to figure it out. And this weird zooming thing that the dock does was a little later. I don't think that was in the original design for the dock, but as people got more and more stuff. And these, the dock and the taskbar was only for open windows, and there's a separate section eventually for launching applications, so they were very separate, whereas the dock kind of combined those, right? So these are either open or closed, and if they're open, they have this little arrow on them or something to show you that they're already open. Otherwise, they look pretty much the same. The start menu, I guess we should have a slide for Windows 8 and the tiles on the front as the current version of things that are going on. Is there anything new in the Macintosh since the dock that have something to do with icons or the desktop? The spotlight search, I mentioned that.
The Launchpad.
Okay.
So that's kind of like iPhone, iOS view of all your applications in one big view.
Okay, so it's just a big array of icons?
Yeah.
Okay. I mean, so that replaces having them here? Or
No, it's
in addition, yeah. Yeah.
There's things like the KD4 Plasma widgets, where
Okay.
rather than the desktop being some specific thing, you kind of put in. It's sort of the same as Windows, but they live entirely in the window manager itself for micro applications.
Okay. Don't understand that, but it'd be probably good to look it up.
Recently, Windows 8 actually reintroduces the tile video thing when you're in the network mode. So you can have two different apps side by side. I think that was 3 now, I think one. You can adjust. And they, depending on how much space the application is.
Right. So obviously on, if you think about the smartphones, they only have one window showing at a time. And so a lot of this, design requires that everything be separate. And then when they expanded that to iPads and tablets, then you have room for a little more space, so they put things side by side. So certainly, kind of going back to some of this stuff about tiling and keeping things side by side and figuring out what % of the screen should be for each part makes sense. So it's interesting that the launcher, idea of using an array of icons, which dates back to the star pretty much, still is kind of the way we're doing things, even though it makes perfect sense when you have 20 items, and it kind of breaks down entirely when you have 100 or 1,000 items. Then you're kind of at a loss for how to arrange them by hand. How many people have hundreds of icons on their iPhone? Or no, nobody does. Okay. That's because these represent applications instead of files, right? In the star, they were supposed to represent both, and so it doesn't make sense when you have hundreds of files to try and do that. But in these architectures, you really don't have files at all. You have the data that goes with each application. So the Notepad app has its own array of notes, and the Contact Manager has an array of contacts. And you can do things like spreadsheets, which certainly then kind of have to have a notion of files, and but it's not like in the PC or the Macintosh where you have a collection of files and then you can have a variety of things that operate on them. So on the Palm, you did use scrolling in order to get to the other icons. On the iPhone, you flick to the next page. They're by pages. Really not that innovative compared to some of the systems that we've seen for the desktop. You can search for icons by name, which is one way to kind of get around the fact that, this doesn't really deal very well with a really large number. Any other concepts that are new for phones or operating systems
I thought actually on both the notification trays.
that slide out from the edges and so forth?
Yeah, or that live inside of a panel, depending on which system you're on.
Right, so, yeah, I'm not sure that's, certainly the interaction technique for these guys where you can swipe down from the top or up from the bottom, and you get this collection of things that you can then interact with, or notifications or so forth. The idea of having notifications in a window pretty much dates back to the original systems. It would always tell you when there was new mail, or if you've gotten, you could set alarms, all sorts of things like that. Or email dates back to the 70s. And the concept of alerting you when you have new email certainly is pretty much just as old as window managers. So the idea of having notifications isn't new. And in the old days when compiling used to take minutes or hours, the systems you'd put the compile window in the background and it would alert you when it's done. And that was actually one of the motivations for the oops, missed it. Sapphire icons. Where did those go? Here. That some of these things this was an alert, and this was the window wants to talk to you, and there was a bug in whatever you were doing, or some error message. So the idea of having alerts pop up to tell you things when things are happening in the background is pretty old. Okay. So I designed this to be a shorter lecture because I knew we were going to run over with the previous one. So if you can think of any other kind of, also we're going to be covering most of these topics in fairly good depth with our guest lectures next week, and both of them were interested in making it interactive, so it would be great if you read the material that they put up and were ready to ask questions so that we can have it be more interactive. Thanks.